a casual, I'm casual. So have questions as we go along. I don't mind. Is it not? There you go. Oh. Okay. How many of you, most of you, how many of you had statistics? Okay, everybody's had statistics. Do you feel like you remember or know? Maybe no, yes, maybe we don't know. Or did it just kind of blow by and you don't know what hit you? Maybe, kind of? Or has it just been too many years removed? For some of you, it's been too many years removed. For some of you, it just got through it, but you don't know what happened. I felt that way about organic chemistry. Like if you gave me that model and told me to, I could tell people that you need to take it. But if you ask me any questions about the subject matter, forget that. So what do we have in store today? So we're going to talk about, you're going to have me for 4.5 hours. Sometimes what are we going to talk about? I think last time I went over, surprisingly, I don't know how. So I guess I could yapper away about this stuff, or maybe you ask really interesting questions, or maybe you reply group, I don't know. So we'll just give an overview about stats. Today it's not meant to be, oh, here's how you calculate a t-test, we're going to use your calculator to do anything like that. It's a lot more conceptual today, just so that you get the big picture of what stats is, so that when you get into the details of whatever your program offers you, it's not going to be as intimidating because you understand the overall purpose in the first place. And in terms of comfort level, just know this. I can handle doing stats, but if you told me to download an app, I don't know how to do it, but my kids do. So I can do statistics, I think, or yeah, if I can, I think you can, because I'm sure you know how to download an app. Okay, so, and then from 5:30 to 7, we'll do some exercises to kind of reinforce the concepts that we're going to cover. Then we get to eat, and then we'll talk about interpreting journal articles, because I believe on your laptops you have access to articles that I just gave as examples, and we can just get used to looking through an example and getting the main points out of it, because we know that we have to get articles. It's one thing to get the articles that are relevant, but it's another thing to get, it's like getting an orange and you feel like you have to pick out every fiber instead of just, okay, let's just squeeze the juice and just get that part and that's all we need. You know, so we'll get used to getting what you need out of whatever it is. Okay, so, all right, so let's begin. I kind of talked about okay, so no, I didn't exactly. So lecture objectives is to develop a conceptual understanding of what statistics are and their place in society and, of course, in your future career. What else? The distinction between quantitative and qualitative research, because those are the two main kinds of studies you're going to come across. Maybe the only exception for some of you would be reviewing case studies, but otherwise the bulk of research would be either qualitative or quantitative. What else? We go a little bit into more detail about quantitative research, specifically descriptive and inferential statistics. How many of you are in programs where they'll have to do a thesis or a project of some sort, or you don't know yet? Okay. And some of you maybe not, but okay, that's good to know. Getting some hands-on experience with interpreting descriptives. Okay, so we're going to do all of the above. Okay, so what is statistics? All those things, statistics, data collection, interpretation, et cetera, et cetera. So what else? Why study statistics? Well, it's kind of like a diagnostic test, right? So, you know, I work with people who want to be physicians, that kind of thing. They run diagnostic tests on patients. So statistics is sort of the same thing, where you run a diagnostic test on a sample of a larger population that you're interested in. We never get the entire population of interest typically when we do statistics or when we run research. You know, the intention is to get a sample of the population of interest, and then you're trying to make some inferences about the larger population based upon the sample that you got. So, first of all, you need to get some good specimens so that you could run the test. Specimens mean, you know, a little chunk of the population. So anyways, I went to Costco the other day. You go to Costco. What do you do when you go to Costco?
Sample.
Sample! and so theoretically, if we were to extrapolate what a sample is at Costco, the sample that you get is what? A representative of the what? The product that they're trying to get you to buy. Is that sample always representative of what you might get if you bought it? What do you think? Yes, no, maybe so? It could be? How many said, well, okay, so for somebody who said no, why no?
Might look it differently.
Yeah, they might have a different, vessel that they cook it in, right? They might put a little extra something. They know how to cook it, compared to me, who might just microwave it. It could be just in what they cook it in. It could be that batch. And how many people say yes, it is representative, though? How many say yes, it's representative? Oh, you're shy. It might be representative still, right? Because if it's something as simple as microwaving it, it's probably going to taste. If I do the same thing, I bought the package, it's probably going to taste something like that, right? So, but as you can tell, a sample may or may not be representative of what the population is, and so our job is to try to get the best sample possible. And one thing important to realize about research is we can't always take every single study we see at face value because their sample, or let's put it this way, we can't automatically always assume that the sample in this particular study is representative of the population of interest for me, because it could be something quirky about their sample, it could be geographic location, it could be, maybe a slightly different cultural background or demographic background or whatever it is. So, there's always the impetus potentially to conduct, even if there's one study that says, oh, this is what this is, like let's say, drinking vitamin water is not, there's no conclusive evidence that vitamin water has any benefits to you in this sample of high-performing athletes. What about recreational tennis players? Maybe it does, So there's always a good rationale like to replicate something in the population. So that's one thing. So we talked about this, many undergraduates. So all of you did take statistics, so obviously it's there for a reason. Just curious, if you feel the importance of, I don't think personally of it, but do you feel like you, first of all, got something out of your statistics class, or did you at least see the importance? So I want you to tell me, what did you get out of your statistics class? And if it's nothing, that's okay. If you want to find that. Yeah.
It was beneficial because I was able to use the skills later on in my undergrad and labs going on.
Okay, so you actually were involved in a research lab, so you had to run some of these tests, or maybe at least set up maybe collect data or something related to the study. Very good. Anybody else? Yeah.
Just looking at some studies do work and others don't. So looking at what went wrong or
Yeah, exactly. What went wrong, what didn't, because sometimes you can think about how the study was set up or the people that were surveyed in the first place that might have made the results different than expected. Very good. Anybody else?
I find it interesting that researchers are able to find associations with different variables like age and whether or not they're gonna get a certain disease later on in life.
Yeah.
Right, that
Age of onset for different diseases can be very distinct, sure, depending on different kinds of cancer, different kinds of chronic conditions, etc. Yeah. Very good. Anybody else? Okay. So what else? Because you should be able, and you know what? Even for stuff like non-health related things, statistics is useful because, for example, one big push for four-year graduate, there's like a big, I don't know if you noticed, but there's a big push for four-year graduation rates at Cal State Fullerton, and that's for obvious reasons, because they want to get more students graduated with degrees in a more timely manner. But it's also because they did some kind of research where they found that students who took 15 units of classes actually, this is surprising to me, but But they conducted research where they just asked students how many hours of work they need, how many hours a week they work, how many units of classes they take, what their GPA is. And they found out that students who took 15 units of classes actually did better GPA-wise than students who took less than. So that's kind of an interesting pattern, kind of counterintuitive to what I would have predicted. But I don't think they counted into like hours of work. So if somebody works 40 hours a week, that probably doesn't apply as well. Anyways, but that's all research, and you may be using research at your workplace that may not necessarily be about health. Yeah. Let's see. Well, yes, what's going to happen to all of you is that you're going to be reading research articles, case studies, quantitative studies, qualitative studies. So, you know, for the rest of your life, if you continue to at least read or be up to date with the journal articles that you might get because you're a member of your society, whatever your profession is, you'll be able to better critically read the article and kind of make decisions for yourself and then take it at face value and say, oh, because the researcher says this is true, this is what I think it is, right? So it's good to be able to have an idea of what happened above and beyond what an expert can tell you. Because, you know, sometimes, I mean, I have to say, sometimes people say, oh, I'm a statistician, so you should listen to me. But in reality, with a basic knowledge of statistics, you can kind of make out stuff for yourself. So you don't have to underestimate your abilities to look at something and say, but do you think it could be because, and I say, oh yeah, that's a good question. Yeah. All right. The research process, developing an evidence base. So basically, this is a scientific method. I know for a fact some of you in PhD students, right? You would have, some people who could be in PhD students, you would have seen this. You might have seen this in your research methods class as well. What we do is we generate a theory. Where do we find the theory? You had to look up theories. If you looked at the articles, for example, that you have, you know, watch what it is. Where would I find theories in a peer-reviewed journal? What are the parts of a peer-reviewed journal article? There's the, starts off with the introduction, then the methods, and then the results, and then the so where would I find if I was staying up till 4 o'clock to work and I, you know, just want to get through this, and if I had to find a theory for my class the next day, what part of the article would I look at? Oh yeah, usually in abstract, maybe, perhaps. But if you wanted a little bit, a snippet of detail, in the introduction, usually they would describe the theory, and then, oh, let me look up that theory some more, you know, and then you could find the original article for that theory. So that's one way to find a theory. So with the theory, what happens is, okay, now you know the constructs of your theory. Constructs are the basically the building blocks of what causes what, right? The causal flow of relationships between things, right? The theoretical framework. So from the theory, you could generate hypotheses. Hypotheses, now it's coming down to actual practice where it comes down to, okay, what am I going to put on my survey? You know, what am I going to put on this? And that's going to be theory-based, right? So again, where would I find, so to do that, what you put on your survey are variables, questions that you're going to ask, that kind of thing, right? And so if I had to kind of, and here's another thing, the whole name of the game is you don't want to just create some questions that you find are interesting. What you have to do is be informed of what's out there, right? You want to see if there is a particular variable or instrument used to measure, like, for example, depression, right? You don't have to make that, you don't invent the wheel for that. You look up the literature for that. And if I'm going to look up the literature for that, where do I find that? If I want to find out, oh, what variables do I want to put on my survey? Where would I find that? And then the journal article, the intro or methods, yeah. So, you know, what they would have done, the people who wrote the article, what they would have done is they would have cited the original source. Or it could be the original source or article you're looking up, and ooh, yay, if they have the actual questions and answers there, yay, you could just copy and paste them. Otherwise, you might have to trace it back, or occasionally you might even have to contact the author and say, could you share with me your whatever scale, right? A lot of times you can find it if you Google search. You can find it as a PDF file or something. So, okay, I kind of have an idea. I got a theory, and from the theory I got hypotheses. So I got my survey together. I got IRB approval. Is that something you covered along? That's something that, if you're going to do research for a project or thesis, most likely you're going to get IRB approval, which is an institutional review, which is not too much of a hassle, but just nevertheless something that needs to be done. Make sure that participants are treated ethically. Collect the data. So what's another thing you've got to do? Well, once I got the survey together, I have to figure out who I am going to collect data on, right? So you have to think, it's kind of a marriage of two things. From the research I've done, I've been in a lot of journal articles and trying to collect data, research projects. So it's a marriage between two things. I have to critically think about who constitutes my population of interest. Okay, so for example, currently I'm still involved in research. It's with St. Jude Medical Center, Healthy Communities Initiative. So St. Jude Medical Center, right across the street from where my husband works, they actually share the same parking lot. They have this Healthy Outreach Initiative branch of St. Jude where they're interested in doing outreach to the community, because what they want to do is prevent obesity-related morbidity, because they want to reduce the number of visits due to, hypertension, diabetes, those kind of things, as well as, oh gosh, what happens, the heavier you get, the older you get, not just hypertension, diabetes, cholesterol, all that stuff inside your guts. What happens otherwise when you're heavier as you get older? Heart diseases, yeah, those things, yeah. We talked, yeah, the heart attacks, the strokes, and that kind of thing. What else can happen? If you were a hospital administrator, what would you try to prevent? Hint, as the population gets older. Yeah, I think old people fall no matter if they're heavy, light, or whatever. I mean, maybe if you're lighter, you will maybe not fall as much, but what happens after you fall, right? So if you have stronger bones and you're a little bit leaner, you might survive that a little bit better, right? You may not need a hip replacement as quickly if you're, over the time, right? From overuse or wear and tear, right? So those are the kind of things they want to prevent. So that's the kind of stuff I do. So when I do my research and I'm thinking about people I want to survey, I have to think, okay, who's the population interest? Well, for St. Jude Medical Center, I have to think about who they serve. They serve the communities of Winnet Park, Placentia, Fullerton, and La Habra. So I pretty much want to try to get that population captured in my study, because outside of that, I mean, let's say I got people in Newport Beach, probably wouldn't work, right? So there's that kind of thing. So those are important things to consider when you do your own research. Did I? Oops. What else? And then you analyze the data. That's where you're going to learn different softwares, different programs. You might end up using different things, like in the psychology department. They use this new program called R, which is not very intuitive to me. Another one that's commonly used is SPSS, but there's other ones. And the bottom line is, don't be overly freaked out with what you learn. I mean, just know that the concepts are the same no matter what software you use. Okay, so maybe using a particular software may be initially intimidating, but just know that the concepts are the same. And the nice thing is, you know what? Honestly, just being called a quote-unquote statistician sometimes for different projects, sometimes somebody will ask you, oh, run a blah, 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 blah. And I barely know what it is. I was like, yeah, I'll do it. And I just started looking stuff up and figure out how to do it. Really, you don't have to be an expert. And that's kind of how I've learned over time, too. I just like, oh, I'll do it. I'm not sure how, but all right, do it. What else? Statistics, analyze data. And then from the analyses, you make a conclusion, right? Did your results turn out as expected, or was it different? If it was different, why do you think it was different? you know, usually in research, it's not too surprising that all the hypotheses you might have may not turn out what you would have expected, but then, you know, it's your job to say, well, why did this particular result become different? Okay, so like for the instance where they say, oh, more units means you do better in school. I mean, you know what? I bet that's good for 18-year-olds to 20-year-olds who don't have kids, who work very little to not at all. And perhaps those who live with their parents, who don't, you know what I'm saying? That I bet that would be the case. But if you had a sample of people who were working individuals, who work full time, have kids, it may not work. Maybe it does, but I wouldn't be surprised if it was different. That's something to think about as well. Okay, so what else? Okay, any questions? You're quiet. But that's okay. I used to never talk to my professors when I was younger, but don't take me for example. So I'm not the best example of that. All right, theories and hypotheses. Okay, so we talked about theories and explanation of why something. Is this some kind of basic? Like, I don't know. All right, is an explanation of why something's happened. So does some people know some examples of some theories that you've used in your classes? Anybody want to talk about it? What are some theories that you come across? The word. Oh, tell me about a helpful leaf model. Tell me. In a general sense.
It's the perception of other people and the beliefs that they have.
Like subjective norms, like what I think my friends think is cool. And that's going to influence what I do, right? Very good. Like, for example, my daughter, she was okay eating applesauce with having carrots in it until one of her classmates pointed out to her, look, there's a little carrot thing on the, you know, you're eating vegetables. Oh, and then she doesn't want it anymore. So that's norms, right? Okay, that's to do with norms. Okay, vegetables aren't cool, but left alone, she would have been okay with it. Okay, good. Yeah, that's helpful leaf model. Anybody else? So in that case, you create a survey that says something to the effect of, oh, yes or no, my friends think that vegetables are cool. Okay, that's what something that current survey. Okay, anybody else got it? Nobody knows? Okay, we'll come across this later. I'm trying to think of something right now. Oh, well, there's the social ecological model that individual behavior is a prediction, you know, so that you don't live in a bubble, right? What happens is your behavior is going to be determined by not just your background, maybe, but also, not just your background. It could be the school, you know, your school environment. It could be your home environment. It could be your surrounding community. So you could maybe be you have great parents, fantastic parents, but maybe they can't help you in school as much because they didn't grow up going to school here, right? Or it could be that you live in a neighborhood where it's not safe to walk around, so that could influence your behavior too. Okay. So those are some theories. Hypotheses are a specific prediction that is based upon the theories. So we kind of hit that on the head now. Variables. So variables are used, so the variables are the actual questions, right? The variable is characteristics which the data can be collected on. Data can then be recorded for statistical analyses if you're doing quantitative research. Okay. And when you're doing quantitative research, we're talking about relationships, same thing. Yeah, you want to kind of think of the variable that's going to be the cause kind of variable, and then the variable that's going to be the effect kind of variable. Okay, you want to make sure that's captured in your data to know what's the relationship between this and this. What if you were doing a clinical trial on a new ADHD medication. And you have groups of people. You have one group that's gonna get the new medication, and then you have another group who gets the tried and true medication that's been around for a while. So you have two different groups, and the outcome variable is I don't know, some task, like maybe some memory task or concentration task or something like that, right? What do you think the independent variable is in that particular scenario? The medication, right, so you'd have two groups, one who got this group, one who got that group. So that would be, so any kind of clinical trial or program that you test, right, you're gonna have an independent, the group, whatever, is gonna be your independent variable. You're not compared to so what else about that? Okay, so that's it for now for that. Presume comes the outcome, risk factor, protective. Oh, speaking of that, when it comes to just having a group, treatment group, control group, would it be cool to have a group that has no treatment at all? ADHD students to have no treatment at all, is that cool to do? Do you have to have that scientifically? Must you? Yeah.
Would that be considered a control group?
You could have, okay, so yes, it would be control group, but would that be a cool thing to do? I'm just giving them no treatment. I think. Maybe not. Maybe. Any thoughts on that? How about a cancer trial? Do we have some people get no treatment at all? Stage 4 cancer? There's a new experimental drug. Would I have a group in that case? And they'll be blinded, right? So you don't know which condition you're in. Would you give somebody a true placebo in that case? No, because why?
It's not ethical.
Exactly. So what usually for stuff like that, for those kind of things, you'd give the standard of care would be the control, like whatever the usual is. It's well established, this is what we do. And then you're looking to see if the new drug, the new experimental drug, is more effective above and beyond what the usual care is. So that's what that is. So you would never have to have a true control group. And probably you wouldn't get it through IRB approval either. So just so you know that. All right. And you wouldn't simply leave it to having, rules. When you have a theoretical model, you have things like the subjective norms, like for example, for the health belief model, subjective norms, which influence your attitudes. So what you think your friends do will affect your attitudes towards it. So my daughter's saying, oh, my friends think that vegetables are awful, so therefore I think vegetables are awful, which means I won't eat it. So that's health belief model right there, right? You wouldn't leave it as simple as just those variables that you put in your survey. What other variables would you put in? Because there could be some other stuff, right, that's not part of the theory that can influence how people respond, right? So what do you think some of the things, like for this little applesauce with vegetables in it study, what other data would I collect on these kids? Gender, right? Gender could be, maybe boys could care less what their friends think more than girls, possibly. So I would put that in, sure. What else? Age, right? So maybe, that's a weird thing, right? Because teenagers can maybe care more, or maybe they could care less with that kind of stuff as they get older and they care about other stuff instead. So yeah, age is an important thing to consider, right? What else? Oh, could be.
SES.
Yeah, brand could potentially, Potentially SES, sure. Socioeconomic status, it could be that. Well, what do you think? Why SES? Why would you?
Because if that's the only thing that you're not going to care about what.
Yeah, that's true. Maybe if they don't have a darn much to eat and if they have empty cupboards and they don't care. Yes, good. All right, all good ideas. So those are the other things that I would consider in my survey as well. And a lot of times the literature you look at will inform you of some important other variables to put in your survey. Okay, so testing the theory of planned behavior. Well, this is another example of a theory. Yeah, because behavior, kind of like how belief model, the norms, the attitudes. Affects intention, which in turn affects, influences behavior. Ask people, okay, okay, we've been talking about that. So what happens also when you have a theoretical model like this? You might come across papers like this when you're doing your lit review. You'll come across a diagram like this, right? And what will happen is they'll put statistics on top of it where you see these numbers, right? Like, oh, this path is significant, this path is not significant. So what this path is saying basically is that theoretically this should influence this, which should influence this, and this influences this, But what will happen is when the statisticians do their fancy analyses, what they might find is evidence for this connection, let's say, behavior control, like I can control my behavior, which leads to intention, right? But it could be that, even though this path was hypothesized, it didn't pan out when they collected the data and did the analyses. So sometimes you might come across, and that's basically what those kind of articles are saying. When you see diagrams like this and you see solid lines and then dashed lines, probably the dashed lines means it wasn't as significant or not significant at all, and then the solid lines means that path is significant. And you don't have to get, okay, so you don't have to have an advanced knowledge of statistics to read through to figure that out. Just look at the diagram and you could probably say, oh, that's what that is. So you don't have to really understand statistics fully to kind of get the gist of some of the higher level analyses you might come across in the studies that you see. Okay. This is, the only reason I put this up here is, for example, for any kind of profession that you're getting into, whether it be with some of you social work, some of you public health, some of you speech language pathology, at Kelsey Fullerton, very cool. My daughter, she did the speech therapy for 4 semesters here. It was a great program. I like the graduate students a lot. So be mindful, and you're probably going to be introduced to this, whatever program you're in. Your department chair or your faculty in your introductory class will say, oh, you should get familiar with this society because it's one of the major societies for our profession. Even for me, for advising of a society that I've gotten used to, more familiar with, is a national NAAHP, National Association of Advisors for the Health Professions. So that's one, I go to their conference every year. This last few weeks ago, I went to DC to present at a conference there. So those such opportunities might arise. Whenever you get a chance to be involved in such extracurricular things, those are good things to do. If there's ever opportunity to do research with a faculty member, great to do. If you could ever publish together on an article, great thing to do, especially if you're looking to do a PhD later on. Always look for those opportunities. If there's any conference that's relatively cheap and local, go, by all means. And usually they give student discounts for that kind of stuff too. Okay, what else? Quantitative versus qualitative research. The thing about quantitative research is usually structured data from which you conduct statistical analyses. The conclusions are objective. Data is usually collected with surveys and experiments. Qualitative research. How many people have been involved? Has anybody done any kind of qualitative research at all? Yeah.
I've done quantitative.
Oh, tell me your experience.
That's currently my job. 2 months ago, I did it for a year.
For the MPH program?
For my job.
Okay.
So at the center where I work at, we were collecting data through a grant that we received from CHU, the Health Advocate Program project.
Oh, because you work with Jessica Jones in the Center for Health Neighborhoods. That's right.
So it was a combined mixture of both.
In the Fullerton area.
Yes, with residents. So for qualitative, we did have small groups, some focus groups as well, collecting from we had our tool was a survey.
Mm-hmm.
It was 5 pages long. We had questions or yes and no.
So that's a quantitative.
Yes, qualitative.
Uh-huh.
And then our qualitative days were more in-depth, asking questions. do you have Medi-Cal? If you do, please explain which ones. And then we went into depth about what kind of Medi-Cal, and if they didn't, why didn't they get access to some sort of insurance plan? What barriers have they faced in receiving, or if they're undocumented? So it was more detailed and more writing based than number based. So that's to expect that we have to do.
And very good. So qualitative and quantitative data both have their place in research, sure. Oftentimes I use quantitative, a lot of times the qualitative data can further inform the quantitative data. So for example, what I think they should do if they had time, and here at Cal State Fullerton, they're saying more students do better at school if they take more units. One thing they could do is a focus group, right? You could probably do a focus group of a variety of people to get their perspective of how that helped them or didn't help them, right? Oh yeah, taking more units kind of keeps me on track and keeps me in an academic mode and gets me motivated, and then there's, you get different perspectives and then you realize, oh, that's why. So a lot of times with qualitative research, I find that people give answers that I would have never thought of. And it would have never, ever been captured if I just did quantitative, right? And just stuck with the validated scales and whatever that I found in the literature. I would say with qualitative data, there's more room to just kind of ask what you had in mind. And you're just going to ask it in an open-ended sort of way that you're going to get, just people's unfiltered responses. So that's one thing. And, for both quantitative and qualitative research, one thing that you'll have to keep in mind is your audience. So, for example, in your research that you do you do it in English or can you not? So you have to do it in Spanish, right? And the one part is doing it in Spanish. You probably want to have somebody who's a fluent speaker, right? Sometimes being of their culture really helps too, would you say? And what else? The actual words you use, you have to, what do you have to say about them? Because, you could have someone translate, but sometimes translation, what can happen with translation? You lose the meaning, right? The meaning is not exactly, so you have to be very cognizant of how it's said so that the meaning comes out the same way that you intended to. So those are things that you have to consider for both qualitative and quantitative research. A lot of times there will be translation involved. And you'd have to, make sure I need to do it for these people. Okay. Quantitative research. So the different statistics. So within quantitative research, so we talked about the difference between qualitative and quantitative. So within quantitative research, you have descriptive methods and inferential methods. Descriptive is just basically, I want to get some basic facts about my sample. Right? So I could easily do that on you folks, okay, this is a class of people I've lectured to. I just want to know their basic demographics. Like, I think I was given some basic characteristics by Anna. I heard that I think there's 20 of you, and that maybe 4 of you are going to engage, 4 or 5, and 4 or 5 are going to search for 30. You are going to something else. Okay, those are basic descriptive statistics, and I can do percentages, all that sort of stuff. If I cared to, I could do graphs and numerical summaries. Okay, so descriptive statistics are used just to describe the data, and you want to do that with your sample. So any kind of so how this translates to you when you see journal articles that you're going to review over the upcoming weeks. If I just want to understand who the sample was that they surveyed, right? I go to the first table usually, because usually the first table that any paper is going to have is a table that has a breakdown of characteristics. More likely than not, they're going to have it. Or if they don't have the table, at the very least, the first paragraph, they're going to talk about it. So if you wanted to understand who ended up being surveyed or whatever, that's where you find it. That's where you find the descriptive statistics of your sample. And then after that, they'll start doing the inferential methods. Inferential is where they actually run the statistical test to see does this theory hold up or not hold up, or some parts of the theory hold up or something. So inferential means that you're making an inference. So it's kind of like going back to the Costco analogy. Okay, I got a sample of data, right? So let's say I got a lasagna tray that I wanted to try, and so I'm going to cut a sample for myself. And I'm going to do analyses. I'm going to do a taste test on this sample to see if I like it. Because if I do a taste test on this little sample, I'm probably going to like the thing, right? More, but not 100% likely, is it? It's just a certain likelihood. There's a percent chance that I love the sample I got, but if I bought the thing, I'm going to hate it for whatever reason, right? So that's the thing about statistics. I think when people get hung up with statistics, it's because there's not 100% certainty involved. You know, so when you add up math, okay, Teddy, what's 2 plus 2 is 4? Okay, well, there's a certain level of certainty. There's 100% certainty that 2 plus 2 is 4. But when you do inferential methods, there's never 100% certainty. We can say with a certain percent of confidence, you know. So that's the way it works with statistics. You get these results, and with those results, there's a certain percent confidence that I have in it. And the kind of the backwards thing, and I'll talk about p-values later, the kind of thing that I think screws up people's minds when they read statistics that everybody gets all kind of about, is that the lower the p-value is, the more significant it is. Because it seems kind of counterintuitive. You would think it would be like 100%, like, oh yeah, 0.99 or something like that. But in actuality, in statistics, it goes backwards. So the lower the p-value is, the more significant it is. And so how that works is, like, for example, if I was testing a relationship, if I go back to this, right? Let's say there was a lack of a relationship between perceived behavioral control and behavior. What's going to happen is this p-value is going to be high. So p-value's probability is anywhere from 0 to 100%. Like when it comes to the weather, there's like a 0% chance of rain or 100% chance of rain. Okay. Same thing with p-values. It goes from 0 to 100%, but then when you put it to decimal points, it becomes 0 to like 0.99 or 1.0, that kind of thing. So the higher this p-value is, like let's say this is p equals 0.63, that means it's very non-significant. It means that there's not any kind of tangible relationship between this and this. So when a p-value is high, you're kind of thinking, not significant. High number means not significant for that p-value. I think this is where people get all hung up with stats. But if this relationship is, like, for example, subjective norms. So, like, if what my friends thinks really influences my intentions because I'm just like that, I really don't care what my friends think. I think I should be like my friends. This p-value is going to be lower. 0.04, 0.03, 0.02, 0.01, 0.00000. That means it's very predictive of the outcome. So the lower, the better. The higher, it's not significant. Better means, it doesn't mean it's better, but more significant or more of what, is probably more support for whatever you're supposed to do. What else? So here's an example of descriptive statistics and numerical summary. Performance of all children in each grammatical category in the 2 interaction conditions. Nouns and verbs. So the therapist, so what you have is the therapist condition. So they have like a 2x2 kind of combination. So they basically have 4 groups here. And I'll tell you how. The 4 groups are this. It's a therapist, so the speech therapist having the student produce nouns, the speech therapist having the student produce verbs. Then you've got the mother, so the mother of the child, having to do the same thing, noun, mother, verb, okay? And 2 interaction conditions, so they have the mean of all children in each grammatical category. Okay, so if I had to look at this, I don't even know what this score means. Maybe I don't even need to know. But if I had to guess, what do kids get higher scores on? Nouns or verbs, what would you say? on average? I mean, are you higher on nouns or verbs? Verbs, right? Okay, got that. Huh. That's not so hard. I can figure, I mean, if I did just to look at this graph, I might think, oh my God, what is that? But if you break it down, I'm like, oh, I got a pattern. Okay. Oh. So what about mother versus therapist? Is that a little bit more tricky? Do you see something clear cut here? What do you think? The mother. When you're looking at, okay, let's do the therapist. Yeah. So mother therapist. It seems like no matter what, they do better on the verbs, right? Regardless of mother therapist. But what if you're looking at therapist noun versus mother noun? Who gets the higher score, mother or therapist? Mother. But what about when it comes to verbs? Yeah, so what does this mean? Does it mean that mother automatically does better than therapist? No, it depends on this. So when they say interaction, so whenever you see something called like a main effect is like, I don't care who does it, they're going to do higher on verbs, right? If it's mother or therapist, they're just going to do better on verbs than nouns. That's called a main effect, right? But we don't have the same thing for mother therapist, do we? It's not like the mother always does better than the therapist, or the therapist always does better than the mother, because it depends. And when you have the word "it depends" on this situation, that's what is called an interaction effect, right? So the interaction effect is that, in this case, mothers seem to do higher scores on nouns, whereas therapists do higher score on verbs. Now, if you were to ask me why that's the case, my excuse is I'm the statistician, I just run the numbers. Right? I don't know, I'm just writing numbers for you. But as a future student, you should know your material well enough so that you can explain it. Right? For me being the statistician, sometimes I produce stuff, spit some stuff out, and I don't know what it is exactly, here it is. But then I discussed with the principal investigator so we can kind of come to some conclusions why this might be the case. And that's where you would work with your advisor. So whenever you have to do a thesis kind of thing, you want to have that productive office hour communication where you say, hey, this is some interesting pattern. Okay, so this is a main effect, but this is the interaction effect. What do you think? And it'd be cool to get don't be hesitant to get your advisor's perspective, because they know the literature a bit more than you. So don't be shy to have those kind of conversations. Okay. But if you understood statistics a little bit, it's going to give you a more informed discussion with your advisor. Okay. Another piece of advice I'd want to give you when it comes to running stats, I know it can be kind of intimidating. But, in your day and age, you have the internet, so you could YouTube everything, right? Figure out exactly how to run stuff and just do your best. And then, and if you mess up, that's fine, but at least you would have tried, and you would have more informed opinions or more informed ideas that you could present to your professor, rather than just say, oh, I don't know how to do this. What do I do? What do I do? What do I do? And then, you have to kind of, even though that's the urge to get it done that way, you can actually just fuck around yourself. And even if it's a feeble attempt, you're going to have a much more informed, and your advisor would appreciate it too. Okay, and you will actually come out with a better learning experience. Back in my day, when I was a graduate student at USC doing my doctoral program, what would happen is they didn't have stuff on YouTube, and I don't know if they had YouTube those days. But you just had to, I worked on a program called SAS, and it was kind of like a fussy baby, where it would just get all gassy and if you didn't give it just what it needed, right? And so, because you had to type in the commands and then run it, and it will just not run unless you got every space right, or you have to have a semicolon here, or you misspelled something, or whatever. And I would just sit there all afternoon until I finally figured out how to run it. And that's how you learn sometimes. I know you don't have the luxury of that kind of time. But I'm just saying with more practice and just plucking around yourself, you get much better. And that's how you actually gain your confidence. Gaining your confidence is just to get in there and just try, even though you don't even want to start. I mean, I should tell that to myself about using apps. But I'm just telling you, when it comes to stats, same thing. Okay, now this was an interesting graph, descriptive statistics. So this is just data collected on different sugar contents of different foods. You got a sample of ketchup, a sample of peanut butter, a sample of chocolate bar, a sample of ice cream, cake, soda, crackers. And you're like, dang, even my crackers have 12% sugar? Shucks. Peanut butter I thought had no sugar hardly, but apparently that's 9.2% sugar. Anyways, so that's an example of descriptive statistics, a way to graph things. Most statistical packages should give you the ability to produce nice graphs, but you can also, how many of you have done graphs in Excel? Yeah, okay, good. So that's good, because you know what, a lot of the peer-reviewed journal articles, when I've done graphs, a lot of times they come out prettier in Excel, and you can customize it a little bit better. So you end up still using that for your graphics. What else? Oh, confidence. Okay, so this is this is descriptive statistics, just to show you some facts about different foods, right? This is an example of inferential statistics with confidence intervals. How many people have what does confidence intervals mean? Anybody heard of confidence intervals? Yeah, tell me.
Well, so I can't remember.
Go ahead.
I remember like specifically writing the lab reports and we had to use it. Right.
Mm-hmm. Yeah. Or what were you measuring? Pardon me?
I also don't remember the.
Oh, that's okay. Anybody else? What does confidence interval mean? Yeah.
Like if you were to do the test again, what percentage would be, like, would it fall on? What's the number?
Right. Yeah, along that concept. So conceptually, what a confidence interval is saying is, I realize, going back to the Costco example, I am a bit of a foodie. If I had a piece of lasagna, and I rated it as an 8 out of 10, that's the 8 is a rating for that particular sample, right? But then, is that going to be representative of the whole thing, or if I actually bought the whole thing, I like it? So I'll put a confidence interval around that 8. So, it could be as high as 9 for the whole thing, or as low as 7. So that would be like a confidence interval. So if I like this sample, it was an 8. In reality, if I, the whole thing as a whole, if I bought the thing, whatever, somewhere between 7 to 9, I'm 95% confident that my score is going to still be somewhere between 7 and 9 if I bought the whole package for myself. So the thing about confidence intervals, most often they're 95% confidence intervals, which means we're 95% confident that, when it comes to research, that the true population or whatever, so I'm using a sample to estimate the population. And if I got a reasonably good representative sample of the population, which sometimes is hard to do to get that perfect sample, that I'm 95% certain that it's going to fall within a certain range, whatever characteristic I'm getting at. And this is where, like for elections, it gets really interesting. So when they say, for example, when it comes to election time, and they say these two candidates are in a dead heat, it's because if you were thinking about confidence intervals in relation to election polls, it means that the two candidates, their confidence intervals overlap, right? So example, a population of interest. So what is this? This is an interesting fact. So Americans, this is something that I just pulled off of Google. Americans' confidence in the honesty of the elections in general. I just pulled this up like a couple of days ago. And back in 2006, I didn't think that people were only 50% of people are confident. I thought it'd be like 90 something percent. I didn't realize that people had such a lack of confidence. Did you? I don't know. No, whatever. Okay, so what would you say? Well, they don't have confidence intervals here, but if they did, what would happen is, because for the Gallup poll, they're not getting every voter. What they're getting is, and this is a world poll, so honesty of elections in general across the world, so not just the U.S. So in reality, what they're doing is they're polling maybe a sample of the population. So let's think of the population of interest. Would it be kids? No, because kids cannot vote, but so it should be people who are eligible to vote in a given country, right? So maybe it would have to be citizens. They would have to be adults, right? And whatever other criteria that a given country has, right? And so if you look at the confidence intervals, right, for these, confidence intervals would be for each point here, there would be confidence interval. And at the points where the confidence interval overlaps, okay, this is where it's like, oh, I don't know if yes is more than no, or if you were to compare different years, right, and the confidence intervals overlap, so probably you could say percent yes is the green. So you could say, 52 from 2006 to 2007, I would say that didn't change much. From 2007 to 2008, maybe it kind of dipped, right? Where it became significantly lower, right? And then what happened over time? What happened in 2016? What do you think happened? It really took a dip, didn't it? And so even though there's so you could say, oh my God, it really changed really fast, right? And I bet you that, okay, so when the confidence intervals do not overlap, it means it's a significant change. That's what that means. So would you say this is a very significant change? Probably. So if I had to put a p-value in terms of change over time, I bet you the p-value is going to be pretty low, like 0.01 or 0.00 something, right? Yeah, definitely. But if you were to look between 2013 and 2014 and look at the change, well, they look about the same. So I would say the p-value for that would be 0.9, right? If I was to compare 2010 to 2011, there's some change, but it looks like the confidence intervals still overlap. So I bet that's not statistically significant, even though there was a bump up. Does that make sense how things, how it all works, confidence intervals? And so when they say the statistical dead heat when it comes to any kind of election poll in November or whatever, it's because for the two candidates, the confidence intervals overlap. And when there's a clear lead, it's going to be that the confidence intervals do not overlap. So conceptually, that's what that looks like. Any questions so far? Okay. Oh, and this is a close-up example with confidence intervals where you actually have them here. And by the way, you can hand calculate confidence intervals. There's a whole equation for it. A lot of your statistical software packages will actually calculate it for you. The effect of vitamin C on tooth growth. I mean, this still happens to be a nice visual that I came across. Okay, so, and you know what? This is kind of interesting. So, if you had to extrapolate these findings to humans, because I'm guessing, okay, guinea pigs are mammals, so we're mammals, so maybe these findings are applicable to us, perhaps. So, if you were a nutritionist, what would you tell your patients, your pediatric patients? What would you get out of this and tell your patients? You had to read this. What do you think? What is this telling me? You got to make a story about it, without me saying anything. So I'm assuming that having a good tooth length is a good thing. Means you're growing, I suppose. And like for kids, okay, they're growing. Probably if your teeth are growing, then you're growing if you're a kid. So I guess more growth is a good thing. So if I wanted you to grow more, what would I tell you?
Drink more orange juice.
Drink more orange juice unless, well, the dose, I don't know, the dose of orange juice or the dose of ascorbic acid. So let's say I live in an impoverished part of the world. And so I have very limited amounts of things I can give you, right? I can either give you this or I can only give you that. And I can only give you 0.5 milligram of it because, you know, I have too many people to take care of. What would you give them? Oh, yeah, because, okay, at that low dose, oh, this is about interactions, right? Oh, okay, so the general trend seems to be that orange juice on average seems to be better, right? Orange juice on average seems to be better than ascorbic acid, right? As you say, oh, yeah. But then when it comes to a certain amount, does it matter anymore? No, so that's an interaction effect between dose and type, right? But if you had only low doses to offer, you'd probably go with orange juice. So here's the thing about interaction effects as well. I don't know if this is a little too complicated, but so that's another example of an interaction effect. If there was no interaction effect, you know what this would look like? These graphs, even though the heights might be different, the overall pattern would be the same. So, for example, the orange is taller than the blue. The orange is taller than the blue. Oh, wait a second. If this was the same pattern, I probably would have seen the blue somewhere here. But no, oh, there's an interaction effect, so it's not exactly the same pattern across the three conditions. Well, that's what an interaction. So when you hear the word going around interaction effect, I wouldn't be surprised if that's something you come across in any kind of research you do, that they try the combination of two different treatments and there's some sort of interaction effect. It would look something like this. So, any questions so far? Okay. Does anybody recognize what software this comes from? SPSS. Okay, so paired samples, significance tests. So what do you think this all means? So paired samples before and after. So that's an important thing when you run any kind of experiment. Whoa! All right. I'm pretty okay. I've been doing my exercising. I've stayed lean. Big balls. Okay. Paired samples t-test, meet before and after. So before and after, scores go down. What else? So that's what a paired samples is. Paired samples is when you have the same person, same group, same sample before and after, and you take the score before and after. So it gives you the descriptive statistics of the sample. What's your sample size here? How many people do you have in each group? Well, I mean, so you have 4 people, right, before and after. And so that's what it tells you. Oh, and where is the p-value? Anybody know? So we want to, basically with the paired samples t-test, we want to see if 39 is statistically different than 31. Does it say anywhere where if it's statistically significant?
The second is.
The 6, because see, at 6 stands for significance level, right? And it's 0.005. Oh, and the criteria for statistical significance is typically, anybody know? 0.05. Yeah, 0.05 typically. So like it's 1/20th of a chance. So if I have to interpret the p-value, what it means is, you know, given that these two means are so different from each other, like 8 points difference, there's only a 0.5% chance that you would sample 2 groups of people that were so different, but in the population, they're actually the same. So what we're saying is if there was no change in before and after, let's say everybody who did Weight Watchers, okay? Let's say this is kilos. And everybody, you know, if I put, so, and let's say I did Weight Watchers, there was a sample of 4 people and I did before and after, and this is what their weight became before and after. So what this p-value is saying is if I surveyed everybody, tens of thousands of people who've done Weight Watchers, okay, and I got their results, and there was no change at all, like this Weight Watcher wasn't working on, right? There would only be a 1/2 of 1% chance that I would have happened to have sampled 4 people. And this change is not statistically significant. So what I'm saying is, basically what I'm trying to get at is the more different these two groups are, the lower this p-value is, because it's saying that this is really unusual. And really, the population, the two before and after should be the same. This is a really unusual result. But if this was, like, let's say the mean before was 39 and the after was 38.5, likely the p-value is going to be something like 0.9, whatever. All right, the p-value. Well, far enough. Is this where we stop? No? Oh, I guess I go another, 10 minutes? I can. Unless there's any questions so far. Well, one thing I want to do, because I've just been rattling off. Is there some things, because I'm very capable of ad-libbing. So if you feel like there's something you wanted to get out of today that's not quite this, I mean, do you want to go more into, this is what a correlation coefficient is, and this is what you use a t-test or a pair examples, or would you rather is it just having the concepts in general, something you want? What do you guys want? Anything different? And what is your wish list before going further? I'm just curious. Yeah.
Like knowing how to read the tables and the graphs and like knowing if it, like where to find the connections.
Okay, kind of a little bit like what we were doing just now, but some more, which we're going to do, like the picture that looks like lips. I mean, okay, so we're going to interpret that at some point. Anything else? Any other particular wish list kind of things that you, it's like, now's your chance to ask.
I think maybe also like.
Okay. Kind of scenarios.
Yeah.
All right, I could cover that at some point today. Okay, anybody else? Okay, so we'll just keep going on. But I will take, so we're covering what you were suggesting already. At some point we can cover, okay, here's, so for, you're talking about quantitative, right?
Yeah.
Okay, very good. Anything else? Okay, all right. So let's just talk about p-values. So the thing about inferential tests, the common denominator for all of them is that they're going to have a p-value to look at. So p-values are found in most inferential tests you could possibly run. The key thing is to help you interpret the results of your statistical analyses. All right, so the important thing is to interpret the p-value. So the summary, p is less than or equal to 0.05, statistically significant. Anything greater than is not statistically significant. Now this 0.05 thing is not set in stone. So when it comes to pharmaceutical stuff, okay, so pharmaceutical trials, well, boy, you got to take that stuff and hope there's no side effects or that it really does work, right? So there's some serious stuff, right? So when it comes to pharmaceuticals, what do you think? Do you think the cutoff p-value is lower or higher? Lower because you want to be more conservative. You want to make sure that this pill is definitely effective. You don't want to have a marginally effective pill, right, or treatment. So for those kind of studies, the p-value might go down to like 0.01. Okay. When you're doing a more exploratory study, and especially if you have a small sample size or something that's never been researched before, you might have a p-value that's different, like 0.10. So when you see other journal articles and they use different cutoffs, that's probably why. Okay, but otherwise, most often you see 0.05 is going to be, by and large, the most common one you're going to see. The p-value depicted. Well, p-value, which is a shit. So this is where calculus didn't make sense to me. You know, this curve, but I understand it better in statistics. So this whole area under the curve is all the possible outcomes that could happen, right? And so what hypothetically is going to happen is the more common thing is this kind of the middle thing. An unusual result is a result that's way over to the right, where A is very different than B. or very much to the left where B is greater than A. But if there was really nothing different between B and A, we would expect, okay, A is equal to B and that's in the middle. Okay. And so the p-value is the probability of an observed result arising by chance. Okay, very unlikely. So that's why a low p-value means, well, they're different. They're not the same. The more your result is towards the middle, there's not as much difference between the two scores, like the 31 and the 38 before and after. Right? That would be more out this way. But if the scores were like 34 and 35, it would be more towards this way. Okay. What else? Okay, so we kind of talked about this. Social science, typically 5% chance. You could be more conservative. If you're more conservative, your p-value is going to be lower, which means you're going to have, a lower chance. What else? Oh, awesome. Okay, so I'm going to copy and paste this link. So that means I got to escape probably. I don't think I can. Oh, did I have a link? Maybe. Oh, I did. Cool. This is a cool video.
With Braun, you can shave, trim, or style in a single stroke.
Understanding the p-value. One of the most important concepts in statistics is the meaning of the p-value. Whenever we use Excel or other computer packages to analyze data, one of the key outputs is the p-value, or sig. In formal terms, the p-value is the probability that, if the null hypothesis were true, sampling variation would produce an estimate that is further away from the hypothesized value than our data estimate. In less formal terms, the p-value tells us how likely it is to get a result like this if the null hypothesis is true. We will now go through this step by step with an example. Helen sells Choconutties. Recently, she has received complaints that the Choconutties have fewer peanuts in them than they are supposed to. The packet says that each 200-gram packet of Choconutties contains 70 grams of peanuts or more. Helen can't open up all the packets to check, as then she wouldn't be able to sell any. So she decides to use a statistical test on a sample of the packets. The null hypothesis, often called H0, is the thing we are trying to provide evidence against. For Helen, the null hypothesis is that the Choconutties are as they should be. The mean or average weight of peanuts in the packet is 70 grams. The alternative hypothesis, called H1 or HA, is what we're trying to prove. The customers have complained that the weight of peanuts is less than what it should be. So the alternative hypothesis is that the average weight of peanuts is less than 70 grams. Helen decides to use a significance level of 0.05. If the p-value is lower than this, she will reject the null hypothesis. Having decided on her hypotheses and on the significance level, Helen takes a random sample of 20 packets of Choconutties from her current stock of 400 packets. She melts down the Choconutties and weighs the peanuts from each packet. If all of the values were lower than 70 grams, with a mean of 30 grams for instance, it would be quite obvious that the bars did not have the required number of peanuts. It is very unlikely that you will get 20 packets with a mean of 30 grams if the overall mean of all the packets in the population is 70 grams. Conversely, if all the values of the 20 packets were much higher than 70 grams, it would be obvious that there were enough peanuts and that there was nothing to complain about. However, in this case, the 20 packets contain the following weights of peanuts, and the mean is 68.7 grams. This caused Helen to ask herself, does this provide enough evidence that the bars are short of peanuts, or could this result just be from luck? She asked her brother to use Excel to find the p-value for this data, comparing with a mean of 70 grams. The p-value is 0.18. Judging from the data that we have, there is an 18% chance of getting a mean as low as this or lower if there is nothing wrong with the bars. That is, if the null hypothesis is true and the mean weight of nuts is 70 grams or more. This p-value of 0.18 does not provide enough evidence to reject the null hypothesis. In this case, Helen does not have evidence to say that the bars are short of peanuts. This is a relief. The smaller the p-value is, the less likely it is that the result we got was simply a result of luck. If the p-value had turned out to be very small, We then would say that the result was significantly different from 70 grams. In general, we start by saying that the null hypothesis is true. We take a sample and get a statistic. We work out how likely it is to get a statistic like this if the null hypothesis is true. This is the p-value. If the p-value is really, really small, then our original idea must have been wrong, so we reject the null hypothesis. P is low, null must go. A small p-value indicates a significant result. The smaller the p-value is, the more evidence we have that the null hypothesis is probably wrong. If the p-value is large, then our original idea is probably correct. We do not reject the null hypothesis. This is called a non-significant result. The p-value tells us whether we have evidence from the sample that there is an effect in the population. A p-value less than 0.05 means that we have evidence of an effect. A p-value of more than 0.05 means that there is no evidence of an effect. Sometimes a significance level different from 0.05 is used, but 0.05 is the most common one. Disclaimer. This video uses plain language to get difficult ideas across. Some terminology might be viewed as incorrect by a rigorous statistician.
Okay. Let's just write some stuff down. Let's see what we.
What's up, guys? It's been a long time. I'm back here, hopefully to help you guys understand this thing called p-value.
Thank you. All right. Good. So let's write down some basic facts about this test. Kind of fun, huh? Okay, so what was some important things? So what were they trying to test? What was the hypothesis they were trying to test? If you had to articulate what it was. Anybody know? Something about 70 grams. That the nuts were significantly, right, so they were looking at the nuts containing a chocolate bar and they were testing to see whether or not the sample of chocolate bars had significantly less than 70 grams because nuts are supposedly good and you don't want to get chewed elbows, right? So they wanted to say, oh, are you ripping us off and putting significantly less than 70 because that's what you're supposed to have, right? So in this case, the null hypothesis would be, so when they say null alternative, they're saying the null hypothesis is, no, there was no difference. They're the same. You know, what the sample has is not statistically significant than what the population should have, right? So that means null. So null means no difference. So that's another thing when it comes to any kind of research you do, any kind of inferential test. Null would mean like no difference, no correlation, no difference. So that's a basic concept you're going to hear when you do stats. Right here. Oh, there you go. Okay. An alternative equals difference. And you know, difference could be either way. You know, so they were talking about, you know, differences could be one-tailed or two-tailed. So a one-tailed test is when you're saying, oh, well, in this case, they did a one-tailed test because they're saying significantly less than. If it was significantly more than, they would say, thank you, you're generous. I'm not concerned about that. I'm concerned about being ripped off, whatever. So one-tailed test, one-tailed equals test of one direction. It could be greater than or less than. One of the two, not both. One direction only. Two-tailed test. Equals test of either direction, greater than or less than. Greater or less. As a general rule, you're going to want to run two-tail tests because sometimes you get results that are exactly the opposite of what you would have expected. So it's always, it's more conservative to use a two-tail test. If you were to do a one-tail test and you actually predicted things in the right direction, it's more likely that you're going to get a statistically significant finding with a one-tail test. But that's kind of risky because when you're doing the, you saw that curve, when you do a two-tail test, you're testing for either two extremes, 2.5% here, 2.5% there, which is like 5% total. If you're just doing a one-tail test, you're doing all 5% on this one side. So yeah, you have more square footage on one side, but if you predicted something in the wrong direction, it wouldn't even detect that. So for that reason, it's better to do a two-tail test. What else? Okay, so what was the sample size here? 20, okay, that's good to know. And the assumption is that the 20 chocolate bars is representative of the 400 that she had in her factory. The p-value ended up to be what? 0.18, right? The p-value is 0.18, so it was bigger than 0.05. So even though on average, I think there was 68.7 grams per bar that she measured, that was not statistically different from 70. I mean, maybe if it went down to 65 grams, maybe then it would have been statistically significant, but just for their findings, it wasn't significant. What kind of tests? We're talking about types of tests. We want to know what kind of types of tests. Did they say what kind of test it was? They didn't, did they? So in this case, this was a one sample t-test. So that's one kind of test that you could run. Sample t-test. Which is comparing one sample to a population, or one sample to a specific criterion. To make a conclusion about the population. So in this case, what was the criterion for this particular example? 70, right? So the criterion was 70. Was it significantly less than 70 was the mean test over here? And the test was, no, it wasn't different. My time's up for an eat a break. I was told very firmly that it's time for a break. So take a break and we'll continue. And I'll answer questions.
Come back in 15 minutes, then we are.
So greater than 4
Yeah, absolutely.
less than or greater than the number. Okay, and then the two times both. Yes. Yes. And then
Oh, yeah.
My mom bought my back last night. Oh my gosh. I cried.
I know, I thought that.
No, I'm gonna say.
No, it's like for Jared. Yeah. I did see it.
Yeah.
oh, it's already great.